So, welcome back and good morning. Today we will discuss in continuation with the earlier lecture some numerical as well as information based question answers for the GATE and other competitive examinations. The problems that we have selected today for discussion from the recent years competitive examinations, GATE and some other examinations all across the country, and at the same time some short answer type questions. Short answer, I mean, that is also MCQ types, but information based with understanding. I will explain as I navigate to the different problems or different questions. You will find the same question is asked in several years, but the options are a little bit different. So you have to understand the basic theory so that you can capable of developing the understanding and correlate with your knowledge as far as the question options are concerned. So without any further wastage of time, let us move to the questions one after another. First one is pertaining to the CNC programming. Although in my earlier lectures I had not developed any PPT or the lectures for the programming part, but still, as far as the exams is concerned, I have picked up those all questions as well, in addition to the numericals or the fundamentals, for your understanding and how to solve those problems. For meshing a rectangular island represented by coordinates P, Q, R, S, all four coordinates are specified on a casting using CNC milling machine, and end mill with a diameter of 16 mm is used. The trajectory of the cutter center to machine the island PQRS is, out of these four options, you have to pick up the correct one. Now the job geometry is depicted through this simplified diagram. This black color rectangular black plate shows the job itself, and this circle that represents the end mill cutter taking the plan view. You will find that there is yellow color line which connects the center point of the cutter as it navigates to the different sides of the job. And as far as the question is concerned, we have to identify the what are the coordinates of the center of the cutter while moving the cutter from P, Q, R, S and back to same starting point P. The coordinate of the four different points, that is P, Q, R, S, from the given dimension is incorporated in the diagram. So the coordinate of the P, that is the datum, which is considered as 0, 0. So length of the plate will be 100 mm. So 100, 0 is the coordinate of the point Q. Similarly for R and S, it is 100, 50 and 0, 50 respectively. Now we have to find out what is the coordinate of this yellow color square or the rectangle, which is nothing but the center of the cutter. So the cutter diameter is given 16 mm. So if we consider that very concept which we popularly known as cutter radius compensation, we have got two types of options which we can employ. That is G41, which is for cutter radius compensation left, and another is G42, which implies the cutter radius compensation right, which can be employed, and to nullify the corresponding G code will be G40. So G41, I just will mention cutter radius compensation left. G42 is cutter radius compensation right, and G40 is cancellation. So anyway, for this particular problem, these codes are not required, but these are frequently used as far as this profile milling is concerned. Now since the cutter diameter is 16 mm, so that the cutter diameter should occupy a position in such a way so that the job geometry, the 4 different surfaces that would be generated, that should be tangent to the cutter location as the cutter moves on, moving from P, Q, R, S and back to the original point P. So since the radius of the cutter is 8, so you have to just subtract or add 8 millimeter additionally, okay, so that we can get the corresponding center points. So that is why the first point would be -8, -8. Second point, this coordinate of the point Q is 100, 0. So if we add additional 8 millimeter to the x-axis, so it will have 108. And as far as the y-axis is concerned, since it is below the origin, so it will have a -8. So likewise, very easily you can calculate other points, that is R, S, and since the cutter moves along a loop, so that starting point and the end point become same. So once again, P will be the final destination point, which is nothing but the identical to that of the starting point. So eventually the coordinate of the point P lastly will be -8, -8. So A is the correct option. That is what exactly is mentioned over here. So these 3 codes are extremely important as far as the profile billing is concerned. Although it has got no relevance with this particular problem as far as the question is concerned, but frequently these are required while undertaking profile billing. Second question, that is get ME2015. This is a very interesting concept, the interpolator, which we have discussed in our lecture 3 perhaps. As I told, if you go to my previous lectures, you will find in the fundamentals that machine control unit, which is the brain of the CNC machine tool, that regulates or takes all sorts of decision making as regard to metal cutting or machine tool operations. Now within this MCU, once again I am repeating it, that it has got 2 different components. One is data processing unit, that is the DPU, and another is control loop unit, that is the CLU. Now this DPU is responsible for all sorts of decision making. So as far as the hierarchy is concerned, so DPU will occupy the higher level of the position, and CLU is supposed to execute all the commands which are issued from the data processing unit. So one of the major function of this data processing unit of the MCU as a whole, that is the interpolation. This is the most important role. And in several questions afterwards, you'll find the same questions were asked in other years, but the options are a little bit different. So all basically falls under the category of interpolator activities. For this one, control spindle speed. The spindle rotation has nothing to do with the machine control unit or interpolation activities. So coordinate feed rate of axis. So to get the desired geometry, the tool should follow the desired trajectory, that is the desired path, and also maintain the desired velocity as it is mentioned or incorporated in the program. So desired trajectory, that is the position, as well as the velocity, both are important and both are taken care of by the interpolator. So out of these 4 options, the most appropriate will be coordinate feed rate of axis. This feed rate is nothing but the velocity at which the axis are moving. Next, this is also related to programming. Some 3 program blocks are mentioned. Circular arc on a part profile is being machined on a vertical CNC milling machine. Now CNC part program using metric units with absolute dimensions is listed below. So be careful about some key words in the problem statement. In this case, it is mentioned absolute dimensions, and it is in the all the data are, that is the XYZ coordinate values are expressed in metric units. The first block G01, so G01, as you know, it implies straight line interpolation. X30, Y55, Z minus 5. And in the next block G02, X50, Y35, R20. So this implies that G02 is G02. That is the code or the preparatory function for implementing circular arc following circular path following clockwise interpolation. G01 straight line, G02 circular clockwise, and G03 is circular counterclockwise or anti-clockwise. since it is G02, therefore therefore we have to think about the circular interpolation following clockwise movement. Now starting point is x30 y55 and end point is x50 y35. So if you take a two-dimensional coordinate system, something like this. So x30 y55 is somewhere here. This will be 30, 55, and another is that is the end point 50, 35 somewhere here. So this will be 50, 35. Now the question is, what is the coordinate of the center of the circular arc? Between these 2 points, there may be several options to draw the circular arc. Now, for this particular command, which of the center point coordinate will ensure to follow or to implement this particular command as mentioned in the second block, that is G02, X50, Y35. First of all, as far as the Z axis is concerned, this is regarding depth. So depth you need not to bother, because the entire depth is provided at the very beginning of the part, that is in the N60 block number. In N70, the tool will undergo its motion from the starting point having coordinate 30, 55 to the destination point 50, 35. Now if I follow a arc something like this way, okay, so in that case it will be, let us draw it dotted manner. So if it is so, then will you satisfy the requirement? Definitely no. So I cancel it. Because of the fact, if I allow the tool to move following this trajectory, it implies it is anti-clockwise motion. But G02 is meant for clockwise interpolation. So this is not valid. So in that case, what will be the option? If the tool is supposed to move from this point to this point, option will be something like this. So in the, to draw this particular circular arc, because that is how it is possible to generate a quarter circle, that is a circular arc following clockwise interpolation. If that is so, so definitely this will be the center point. So if this is the center point, so what will be the coordinate? For the x-axis it will be 30 and for y-axis it will be 35. So this will be 30, 35. So the correct option will be D. That is the center of the coordinate of the center of the circle. So these sort of simple questions you ought to solve using your basic fundamental concept. This one is for Vizag MT mechanical examination held in 2013. That is also related to the one program block which reads N002, G02, G91, X40, Z40, that part is not required. So as far as this particular command block is concerned, there are two key commands. One is G02, another is G91. So in effect to G02 and G91, out of these 4 options, which would be the correct one? That means which can correctly capture the interpretation of G02 and G91. G02, as I discussed right now, the G02 is a preparatory function of the G codes for implementing circular interpolation in clockwise direction. And G90, 91 are the two commands used for absolute mode of programming and incremental mode of programming respectively. Since it is G91, so definitely it will imply the application of or implementation of incremental mode of programming. So if we combine these two, circular interpolation in clockwise and incremental dimensioning or incremental programming mode. So correct option will be C, which is shown in the green color. Next one. Once again the same question as that of the previous one which we had discussed, that is the interpolation. Similar question, interpolator in a CNC. So what is the requirement or what are the options? Controls spindle speed. Spindle speed is not controlled by the interpolation. Operator tool changer, it is also not valid. Commands CAD circuit, that is a completely different thing. So as far as the interpolation function is concerned, it is regarding the axis movement, which we had discussed a few minutes back in relation to the previous question. So the axis movement, that is the path along the velocity, that is the feed rates. So correct options will be B. Get PI 2019 question. In an NC milling for a two-dimensional circular arc generation between starting point P, that is 60 120 and end point Q 120 60, similar to this one, having radius of curvature R equal to 60, that is reflected in this first block or the first option rather. Which of the following command blocks is appropriate to execute this one? So the tool is supposed to move from starting point P to the end point Q following a radius of curvature R60. So it will be similar to this one, but your starting point, end point coordinates are different. 60 120 120 60. So in that case, in the circular command is implemented in that particular block, but using that particular block where that exact G02 or G03 command takes place. Now since it is moving from 60 120 and 12 up to 120 60, so configuration will be similar to this one, more or less similar. So if you do once again, so 60 120 60 120 will be somewhere here, I am not writing, and 120 60 will be somehow here. Once again, it is supposed to follow a curved path having a radius of curvature R60. So definitely the path will be something like this. sorry. It will be clockwise because G02 is given. So this will be 60 120, 60 120, and this one will be 120 60. So the correct option will be G02, X120, Y60, R60. Because in the G02 block, the end points must be reflected. So 120 60 is the final destination point. So that is 120 60. So that is why out of these four options, G03 will certainly not be the right option. And in the option B, it is X60 Y 120. In that case, the movement would have been different. So to satisfy this particular requirement, it is moving from P to Q, where X value increases, Y value decreases. So definitely the correct option will be the A, the first one. So this is the correct option. The logic is similar to the previous one. One blank slide is there. Okay. This is basically table or the column matching type. So there is no need for detailed discussion. Only thing is that different G codes and M codes you ought to remember. And this sort of question appears almost every year by combining some sort of G codes and M codes. So two such previous year question I had considered. The matching are shown by the different color combinations so that it is self-explanatory. G01 is for linear interpolation, G03 circular interpolation counterclockwise, M06 is the very popular command for tool change, and M02 is for end of program. So if you match like that, your correct option will be option A. Next question, once again, the same type of question, that is the same interpolation. The interpolator in a CNC machine controls spindle speed, coolant flow, feed rate, tool change. So, correct option will be feed rate. Another column matching. So, M05 is the spindle stop, G04 is the dual, G90, which I was discussing a little bit before, that is the absolute mode of programming. So, G90 will match with the absolute coordinate system, and G01 is the linear interpolation. So, correct option will be C. So, with a little bit of understanding, you will be able to attempt those questions correctly. During the execution of a CNC part program block, the command looks like N020, that is the sequence number or the line number, G02, that is the, once again, circular interpolation clockwise. Coordinate values given X45, Y25, R5. What type of control motion? Tool motion will be there. Since it is G02, definitely circular interpolation clockwise. So A is the correct option. That is the first one. Vizag MT Mechanical 2013. NC contouring is an example of continuous path positioning system. In our very early lecture, maybe the first or second one, we had discussed about the classification: point to point, continuous, contouring, paraxial. So from that point of view, so NC contouring, that means path, a particular contour has to be generated. So that implies the tool should navigate following the particular trajectory continuously, so that desired trajectory can be generated. So obviously the correct options will be coordinating continuous path, or the positioning continuous path. One numerical problem from 2022. The problem is similar to what we had discussed in the last question answer session or the numerical problem session. Same type of problem with a different data. So there is every possibility the similar types of problem may appear this year as well. A CNC work table is given in a linear direction by leads to connected directly to a stepper motor. So since it is connected directly to the stepper motor, that implies there is no gearbox in between. That implies RG will be equal to 1. The pitch of the lead screw is given as a 5 mm. The stepper motor completes one full revolution upon receiving 600 pulses. If the work table speed is 5 meter per minute and there is no missed pulse, then the pulse rate being received by the stepper motor, we have to express your answer in kilohertz. So from the table speed, we can easily calculate what will be the corresponding revolution of the lead screw. And since the lead screw is directly connected to the motor without any gear in between, so the motor will also be having the same rotation as that of lead screw. So if we divide the table speed by the pitch, we will get the revolution of the lead screw per unit time. So it is expressed in 5 into 1000 by 60 millimeter per second is the table speed. So the corresponding rotation of the lead screw will be this much. Simply you divide V table by P, you will get 1000 by 60 RPS. As I told, this screw is directly coupled to the stepper motor, so both will having the same rotational speed. So the stepper motor receives the 6000 pulse per 1 revolution. It is already told in the problem. So the pulse rate that has to be expressed in hertz or kilohertz depending on your option of the problem statement. That you have to be careful in the competitive exam. In which unit you have to express your answer. So 1000 by 60 multiplied by 600 pulse for 1 complete revolution. So the total pulse rate will be 10 kilohertz. So your correct option will be B. Get PI 2023. This type of problem we had discussed in the last class. We had maybe a couple of years back. A CNC water jet cutting machine is used to cut a straight slot between the points 21 and 1010 on the XY plane. If the feed rate is 1.5 millimeter per second, what will be the time in second to machine the slot following the shortest path? The key feature or the key word of this particular problem is the shortest path. So while moving from one point to other point, what will be the shortest path? That is the direct line connecting the start point and the end point. That is what we popularly call as a displacement in the class 5, 6 level physics. That is equally applicable here. That means, so indirectly it is told that the tool will have to follow the straight line interpolation. So if the tool is supposed to move from the point 2, 1 to the second point 10, 10, definitely the distance covered, rather minimum distance covered will be under root 10 minus 2 square plus 10 minus 1 square, which is 12.04 millimeter. So feed rate is 1.5 millimeter per second. There is no acceleration, no deceleration. So AC equal to VTT will be applicable. So time will be equal to displacement divided by the velocity. So your answer will be 8.03 seconds. Get AV 2023 last year. A CNC machine had one of its linear positioning axis as shown in the figure, consisting of the same problem which we had discussed earlier quite a number of times. Only thing is that this schematic diagram is given in the along with the problem. If it is not given, yesterday I told you that you have to recapitulate or you have to visualize the very simplified diagram of the open loop system or the closed loop system depending on the problem configuration. So that is what exactly is provided. This is the motor, screw is directly coupled with the screw, nut is coupled and over the nut table. So the rotatory motion of the motor will be transmitted to the screw having the same rotational speed, and the nut will have the corresponding linear movement. And since the table is also directly mounted on the nut, eventually the table will have linear to and fro motion within the its capacity or within the zone. The motor moves in discrete rotational steps of 50 steps per revolution. So the motor has got 50 number of steps. So NS will be 50, pitch is given 5 millimeter, and the total length of traverse is given 100 millimeter. So what will be the total number of controllable location at which the table can be positioned on this axis? This total number of controllable location, that is the important part, or rather it is asked. So this is something related to the basic length unit of the resolution. So what is the concept of resolution? For one pulse, what will be the minimum incremental movement? So if that is so, we have to first find it out what is the resolution of the basic length unit. So from the given data, we have identified NS equal to 50, pitch P equal to 5 millimeter, total length of traverse will be 100 millimeter. So first we ought to calculate what is the basic length unit. So the same relationship P by NS into Rg. Now Rg equal to 1 because there is no gear system. So eventually BLU becomes 0.1 millimeter. So if one pulse causes 0.1 millimeter, so at the gap of every 0.1 millimeter, we have got a control points. So likewise, if we want to divide this entire length of traverse, that is 100 millimeter, so how many controllable points will be there? So very easily 100 divided by 0.1, which is 1000. So the entire table movement 100 millimeter is decomposed or is divided into 100 number of controllable points in between from the starting to the end. So I believe that all sorts of questions we have discussed in these two classes, which will be extremely beneficial for your entering GATE examination and other competitive examinations. So I will suggest at the end that you go through the recap your previous lectures and try to solve similar problems with the understanding and try to correlate. I believe that similar type of questions will be appearing once again and you will be able to solve those problems without any difficulties. Thank you very much for your patience hearing. Wish you all the best.